I'm just killing time and talking gibberish right now. Okay, are we ready? Okay, we are ready. So after this, we'll do the competition. Katerina, give a big clap, clap. Okay, let's do it.
Can you all see me? No. My legs are the best part of my body, so... ναι, τι να κάνω, να πάω εκεί μπροστά. Μ' αρέσει να είμαι όρθια, αλλά θέλω να έχω και πρόσβαση στο λάπτοπ, οπότε να κάνουμε κάποιο σύστημα. Το κόλπο του γορίλα όμως, εγώ θέλω να δείχνω και κάποια πραγματάκια στο λάπτοπ. Ο γορίλας δεν έδειχνε. Όχι, όχι. Με βλέπετε τώρα. Τέλεια. Εσύ με βλέπεις και πριν. Λοιπόν, δεν θέλω να κάθομαι, θέλω να κουνιέμαι για να... δεν έχω δουλέψει πάρα πολύ τα slide, όπως ο Θοδωρής, δυστυχώς, οπότε προτιμώ να με βλέπετε να κουνιέμαι. Anyway, I will start speaking in English now. I don't like it when I talk with Thodoris in some event, because Thodoris always makes his slides perfect, and I look like a slacker after Thodoris. So, okay. Anyway, today I'm going to talk to you about how I code with agents and AI. How many of you use AI to code? Nice. And how many of you go to the lengths of customizing AI, writing custom agents, etc.? Okay, we're going to see some methods today. Obviously, it's not going to be extensive. I'm definitely not the most sophisticated AI user, but we're going to see something, okay? You can follow along the slides. Let's follow here, and I will give you the link afterwards. Anyway, I'm Katerina. As Thodoris said, not Thodoris, the other person said, everybody knows me, apparently. Not as many people as Thodoris. Anyway, I'm a software engineer at Supabase. Who here uses Supabase? Perfect, thank you. So whoever can tell me afterwards where my t-shirt, this line from my t-shirt is from, wins a Supabase bottle. If you cannot find it, I will give it to whoever shouts the most loud. Anyway, I really like cats. If any of you follow me on social media, you will understand that. I really like the mountains and sea. And I'm a Google developer expert for Angular and Google Maps. You can follow me at CyberCity in whichever social media you use. No, actually, I'm only on Twitter and Blue Sky. Anyway, these are my cats. I always like to show them. Oh, their slides are there as well. Ah, okay, Koble. I thought they were only here. Okay, now it makes much more sense. Okay, what does it mean to code with agents? It's not about replacing developers. It's about amplifying their capabilities, let's say. So, yes, you know, there is all this doom talking about, oh, AI is going to replace us. No, it's not going to happen. We are going to be working with AI as a collaborator. And if you use it as a collaborator, it will help you, but it will also make you potentially more efficient, more faster, or whatever. From one-shot prompts that we used to use like 2 or 3 years ago when ChatGPT came out, we evolved into integrate them into continuous workflows, not in self-healing CI, as Thodoris said. I am also afraid of that, and some tools do it. Focus on intent when using AI, let agents handle implementation. I really like this meme here. But if you look at my if you look at my cursor, it's exactly like that. I have my own agents for each project. So apparently, maybe my mom did abuse alcohol and substances when I was in the tomb. Anyway, 37 years later. Today, we're going to explore, let's say, the agent paradigm shift, my AI hours workflow. And I'm going to show you some pre-recorded demos because I dislike live demos. But before we start, we are going to attempt one live demo. As you saw, wait, this cursor here. As you saw, I have set up my nice agents here. And here I have Warp, which is powered by AI. So and this is the repository of the demo I'm going to be showing today. And I have asked AI, again, I am doomed by slow networks. I was having a talk weeks ago, and the talk was destroyed by slow network. Anyway, I have 3 issues open that the AI created. I am going to ask 2 agents to complete 2 issues. Maybe it will work, maybe it will not work. Let's see first. What is it called? Actually, can you see? Agents. Okay, so I'm going to use the GitHub issue handler. Use GitHub issue handler to complete the feature request issue number 1 on this repo. Let's see what it will do. I'm going to talk more about it later, but I hope it will start doing the work. And I'm going to spin up another agent here using Warp's AI. No, I cannot because it will create a branch. Okay, I will just use one. Yes, don't ask again. I give it all the permissions. And let's say it will do it. If it fails, it's okay. So yes, this is the only live demo I will be doing. All the rest are going to be recorded demos. And then maybe some tips on how you can build your own sub-agents. What is called, let's say, the agent paradigm shift is how we evolved from using Copilot to using agents. Who remembers when Copilot came out 3 years ago? We all do. Not 3, more than 3 years ago. It was 3 years ago was GPT. Sorry, 3 years ago. Yeah. 3 years ago was ChatGPT. Sorry. Yes. So Copilot was just autocomplete like tab 9. You know, tab. It was very nice to have, and it was the first, let's say, revolution. Then, usually 3 years ago, came a ChatGPT. And eventually, later, it came Claude, which you asked it what you wanted to do, you discussed a little bit, it created it, you copy-pasted it into your code. Of course, you edit, etc., but you know what I mean. And finally, we have the agentic systems, let's say, where you have autonomous task completion, like I hope my agent here is doing. It's still asking me. I have given it all the permissions, and it's still asking me. Never mind. Autonomous task completion, context-aware execution, which means that you give it first, you define some context, and also it has a context of your whole. This is not just GPT, let's say, that you ask it what you want. And self-correcting workflows, not on CI. Locally, whenever it runs a command, it finds an error. I don't know if you have used Warp or something else for that. It finds an error and immediately it tries to fix this error right in some code. The power of it is autonomous execution because agents can execute and verify. Because when we say agent, we mean that it's a tool that it can call other tools and it can have some planning and it can execute the tasks autonomously. So, for example, if you use Cursor or whatever you use, you will see that before, when you ask it to do a task, it will start writing like 1, 2, 3, 4 steps I have to complete, and it will start completing the tests, executing commands, verifying. Also, it remembers your project structure. It integrates a lot of different tools, MCPs, for example, that we're going to talk about later. And you can spin up multiple agents working on multiple things at the same time. For example, have one agent editing one part of the code base, have another agent editing part of the code base, and have a third agent writing documentation, for example. AI models are calling other APIs themselves. It's like giving the model new skills beyond text generation. Let's say if you add an MCP of, I don't know, some documentation tools, it will just have access to that documentation, and it will be easier for you to ask the documentation. Or if you give it access to the MCP file system, it will be able to perform things on the file system, etc. And it enables dynamic information retrieval and actions, as we explained. How tool calling works, the model recognizes it needs additional capabilities, like now I hope it's still not asking me for things. Yes, allow all edits. Those live demos. It recognizes it needs additional capabilities. It formats JSON requests for the MCP. So for example, whenever you call an MCP, you see the structure of the JSON that is being sent to that MCP. The application executes the tool. Results are added back to the context, result from the MCP, let's say. And the model continues with enriched information. An example of a tool structure example could be like a name, a description, just a typical JSON file. Why tool calling matters? You can read them, for example, if you use the file system MCP, you can read and write files directly in the code base. You can search for patterns across thousands of files and see results, access documentation, not just training data. So it's very, very important to, let's say, enrich or empower the AI you're using with these tools. Yeah, we don't have to execute builds, deploy, manage infrastructure, but of course, whenever you're using tools, the cost goes up. The tool definitions and the results equal more tokens. Cursor has some nice documentation on the whole flow, on how you can understand how the AI models work. A quote from there is, an agent is simply tools in a loop, which pretty much sums it up. You give it a goal, not step-by-step instructions. And the tool itself figures out the instructions and the steps that it needs to do to execute them. So for example, if you tell the agent to add dark mode to settings, let's say, it will start by finding the settings page, read the current structure, create implementation plan, add some state variables, create CSS class, implement the toggle, run the test, fix errors, complete. The agents are very good at pattern refactors across many files, to add tests to existing code, to update documentation. I actually use it a lot to, right now I'm doing some big refactor, moving things here and there, and it's very good at producing documentation for that, and fixes bugs with clear error messages. Of course, it's still challenges, that's why it's not ready for CI. Complex multi-system debugging, pixel perfect design implementation, of course, except if you do test-driven development, you have to test first. Brand new and documented libraries. Think of agents as fast junior developers who need clear direction. So what I do in my AI-powered workflow is whenever I want to build, for example, let's say I don't write front-end code at all, right? So if I want or need to build a front-end demo for some presentation like this, the first thing is I will go to ChatGPT and we will discuss this idea. And I will ask ChatGPT to write very detailed specifications for that thing I want to build, right? And I'm going to discuss it, go back and forth until I have the best specification I can. Then I will throw it, let's say, into bold.new or Lovable or whatever tool you're using that doesn't need coding. And I will get scaffold for that. Git clone locally, add my agents, and start working, let's say. How I work for my actual job, which is just TypeScript, writing TypeScript code, tooling. I have my local agents, and I I use my tools by giving very specific instructions and goals on what I want to do, which I'm going to show you. Yeah, the specification I explained. Rapid prototyping, again, I explained. So let's see. Still, it needs more things. Okay, let's give it a moment. Yes. Okay. I guess now it found an issue and is going to start trying to fix it, let's say. But in any case, let me close this. So what I wanted to show you was AI demos. So whenever you have a code base, and what I do, whenever I have a new code base and I use Warp, for example, I will try to add as many instructions I can for the AI, right? Because if you leave it to do whatever it wants, it will mess it up. And it will also consume much more tokens to understand what it needs to do. So a cool thing that tools have now is that you can init the tool in a code base, and it will try to index the code base, and it will understand the structure, and it will create instructions for itself, which then it's going to be, its whole work is going to be based on that. So eventually it's going to scan the code base and create, for example, Warp is going to create a Warp file. Then, as I said, you can ask the AI to index the code base. No need to see that video. Then another cool thing that tools have, I'm going to show this example from Warp, but we're going to do the same thing for Cloud Code, let's say, is that you can tell the agents which tools are allowed, which tools it can use, and which tools it cannot use. For example, here, I am allowing it to read files, create plans, execute commands, but I do always add a command deny list. So I don't want it to push any code, for example, or I don't want it to RM anything, or I don't want it to run eval, right? So you can add all these safeguards, let's say. Another thing is that you can add specifications to it. So, for example, you can add profiles, and for this YOLO demo, let's say I give it all the permissions I want. I tell it which model I want to use and which model I want it to use for planning. And finally, you can add custom rules, of course, to the agent as you do to the AI. For example, as rules, I always ask the AI to greet me as I want, which node version to use by default, and let's say some general rules about the code I use. Then you can add some agents, right? And what does this mean? Let me open. What does this mean? It means that you can add some pre-created rules that you can use whenever you have something. So for example, if I run into a Git conflict, I can put the context of which is the log, let's say, of the Git, and attach this context to an agent, which I have clearly explained how to handle Git conflicts, and it will follow these specific commands for Git. The same thing within it on the same code base can happen with Claude. It will add a Claude MD file, and potentially it will ask if you want to add some MCPs. But let's see. But for Claude, the cool thing I like is the sub-agents. So Claude gives you an interface that you can create sub-agents, which can be global or project level. And you can create a new agent that, let's say, I don't remember. Yeah, you can create an agent that is focused on writing unit tests. And on that agent, you can give very specific information on how you want your unit tests to be written, like that with testing library, with tests or whatever you want. And I want only the tool to focus on these folders or whatever. So whenever you want to write new unit tests and you have given this specification to Claude, the agent, you can spin up this agent and it will do its work, but confined within the rules that you have given. And Claude has this wizard that helps you write the agent so that you don't have to write it on your own. So here, as you saw, I just wrote a prompt, what I wanted the agent to do, like write unit tests. And the results, yes. And the results was, for example, this whole file that Claude has generated for it, which explains in detail how Claude wrote that, I did not, which explains to your code how it should write unit tests. And you see it's very, very detailed, especially if you have given it before your testing conventions or your testing strategy. It will base it all on that. Yes. Let's see what other video I want. Then you can add MCPs, as I explained. You can tell Claude to add MCPs or add the MCPs manually. The GitHub MCP, I find it one of the most useful things that you can use because it will fetch code from GitHub. It will check pull requests, for example. I can tell Warp to find all the pull requests that I am assigned to, let's say, or you can ask it to review a pull request. It will just help you eventually. Let's see if this, again, you can create a new agent to create pull requests and to solve issues at the same time. And as I showed, you can run agents in parallel. So for example, here, I'm spinning up some different agents. The one agent, I'm asking Claude to use the one agent to create a new issue. And then in another tab, I spin up a new agent and I ask the new agent to open up another issue. And in the third tab, I open a new agent and I ask it to create a new component. And all these are going to be running manually and automatically, and the tools eventually are going to be notifying you once things are done. I think these are the two. Yes. So, for example, I called the GitHub MCP. Actually, here it's called the GitHub CLI, but it's the same thing, almost, not exactly the same thing. And it just tells me which pull requests are assigned to me. And you can even ask it information on this, and it's very, very useful. I use Warp a lot because, I don't know, it just feels more natural to be in the terminal. But also it has all the capabilities I showed. With Cloud Code, the cool thing is that you have these project level agents that I showed, which are pretty amazing. But you can mix and match the two. The most important thing that you have to do is to teach your agent your preferences, right? In that case, it will be more safe when you use your agent or your AI. You tell it which node version to use, what to do, like never push directly to main, which package manager to use, if you want some naming conventions for your components. Of course, this will lead to consistent coding standards. Also, it can have project-specific knowledge and team alignment. And you can add all this to your Warp and D file per project, but you can also set it up globally in the rules. For example, if you want to build a feature, one agent can create API endpoints, One other agent can build the UI components. A third agent can write the tests. The fourth agent can update documentation. Yeah, we show those demos. Let me see if the other thing fixed it. Yes, so let's see if it did create this pull request. Yes, so the agent that we started in the beginning did create a pull request. It connected it to the issue here. And I could even ask Copilot to review it, but I never trust this, never. And of course, and in the commits, of course, a co-author is Claude. What? Okay, I would change it manually, but yes, I didn't know you can do it from the configuration. Just git commit amend author and it goes away before merging, of course. And yes, here, if you have the time and will, you would sit down and just review this PR, which is pretty okay, let's say. And eventually you could merge it. I don't care even if I merge it now because this is not used anywhere, but you see, the AI created the issue, another agent created the PR to close the issue. Let's go back here. Okay, some MCPs that I use is the file system MCP. I'm not scared to use the file system MCP. It's the work computer, so I don't care. I use the GitHub MCP a lot for the reasons I told you. Basically, mostly, to be honest, Supabase is open source, and I have to go through a lot of PRs. What I usually do is I ask Warp or Claude or whatever, find in this repo some low-hanging fruit of issues that we can quickly go through and close, let's say. And maybe it will find some outdated issues or some issues that are, not relevant anymore or anything. It's very useful to triage issues, let's say, or triage community PRs. I use a lot for that. I use the Supabase MCP because it has access to documentation and database operations. I also use an X sometimes, which also has an MCP. But in general, whenever I use a tool, I try to see if it has an MCP so that I can use it. I also use the linear MCP, for example, a lot, because we use linear at work. So yeah, I suggest you use MCP as well if you don't. Yeah, the MCPs I have explained what they offer. They give you direct access to query the API or direct access to the documentation. To build your own you can also build your own sub-agents or custom MCP servers. I personally have not done that, but I was at a conference a couple of weeks ago, and a friend of mine, Michael Klatke, was saying how he does that. Like he has built a custom MCP to parse the AS tree that makes searching the code, his Angular code, for example, or anyway, whenever you use TypeScript, the abstract syntax tree, it makes code lookup much, much faster when you, for example, use an AST parser MCP that he has built. You can build one with AI. And yeah, the MCP structure is pretty standard. And you can code your MCPs to add to your agents, I guess. Now I will quickly go through how we can understand the agent memory. Again, if you go on the cursor docs or just type cursor learn, it explains how context works and how context windows work. I don't know if you, for example, if I don't know if I have anything on Warp here running. Do I? No. Anyway, when you start asking something like explain what the last commit did, let's say, it will start doing some things. Eventually here, it will start telling you about the context window, or if you do it in cursor and you start explaining this code base. So you see here the 13.3%. This is the context window. The context window means how much still the model can accept until it summarizes, and it adds that summary to have the new prompt, right? So as it searches things and as it does things, the context window that is available becomes smaller and smaller. The context is everything the AI can see in a single conversation. It includes your code, instructions, previous messages, and it's limited by the window size. Depending on the model, the window size is different. Larger context, more expensive, obviously. Again, you can do some smart context management, let's say. You can include specific files. So if you want to change a file, don't tell Cursor or Warp or whatever you're using, change, I don't know, this API, just tell it the file you wanted to focus on. You can remove relevant code from the conversation. You can have some rules applied. What are the tokens? The tokens are the words the AI model actually understands. I'm not going to explain tokens now, but and I'm not going to explain tokenization either. But what I do want to explain about the context size is that, as I explained, as the context fills up, at some point it's going to be filled the whole. So what the AI will do is it will take the whole conversation, create with AI a summary of the conversation, and add this as a context for the next prompt. So as you add more and more things to a conversation, if you reach a point where it tips over and it has a summary of the things before, it may start getting less accurate. So you have to be aware of that and either create a new conversation with a new context that you want and you control, and do not base whatever you do on very, very large conversations, because eventually it will just start using an arbitrary summary that it will have created. Yeah, begin with whichever you want. If you have not begun, which I know you haven't begun, but most importantly, build your agent context, because it will help you a lot, especially in what I explained right now. Write like agents, warp MD files, flood MD files, set up MCP tools, custom rules, document your preferences, because as much instructions you give to the AI, the more accurate the results are going to be. The agents improve with feedback. Share your patterns with your team, and yeah, continue learning. I have these links here, but if you go to the link of my presentation, you are going to find all the links there that you can use. And that's it.
Any questions?